My study is about the partnership that Toyo Ito in the last 10 years carried on separately and alternately with three structural designers, Unsuro Sasaki, Masato Arai, and Cecil Balmont. With the construction of the Sendai Mediatek, as it is well known, Ito realized that an attitude which does not take into account the structural design in the early steps of the design process represents a methodological and conceptual error. So, since that moment, he attempted to front this problem involving the figure of the structural designer already in the drafting of his project diagrams. On the other hand, Sasaki, Arai, and Balmont offered innovative methods that integrate formal and static analysis, applying advanced softwares. The hypothesis from which I started is that the three couples, Ito Sasaki, Ito Arai, and Ito Balmont, can be considered as three separated case studies, because each team has developed autonomous aims, methods, and formal vocabularies, albeit with common characteristics. Ito and Sasaki, as is well known, employed computer models to obtain three-dimensional freeforms based on rational mechanical criteria that optimize behavioral structure and that makes the form evolve in geometry. Ito and Arai focused their attention on the expressive values associated with the structure of the building, which as a special boundary determines the final image of the building. Ito and Balmont, finally, through the conversion of the starting diagram in an algorithm, could solve problems with multiple nonlinear solutions in order to obtain changing and unpredictable outcomes, however, always based on an intrinsic structural rationality. The goal of my work is to value the weight that the involvements of Sasaki, Arai, and Balmont had in development of ideas proposed by Ito, and to understand at the same time how Ito is able to take advantage of the potential offered by the method they proposed. So I mainly focused on the analysis of the design process behind some project that I considered the most representative, and that I chose beyond of my interest for the specific solution proposed by Ito. Some aspects of the working method of Ito are keys to understand the development of the tree collaboration. First of all, he thinks to design as an open process, sensitive to the contribution of the specific qualities of involved structural designers, taking care to respect different aesthetics belonging to their specific point of view, such as the search of minimum thickness of the slab, or the extreme simplification of the constructive system, on the refinement of a complex rule of the structural development. So, Ito accepts that the result may be very distant from the starting image. Furthermore, the choice of the professional with which Ito intends to collaborate, as it is habit in Japan, is closely related to the specific topic which he wants to work on. This occurs when it requires an expertise in the use of a particular material, such as aluminium in the projects made with Arai, or if some designers develop a structural innovative method for the calculation of particular structural types, such as the methods for the design of free shell structures developed by Sasaki, or more generally a method for the analysis of and the development of the wool project, as in the case of Gamboni. A final factor that affected these relations of cooperation concerns the instrumental use of information technology that it suggests after he had considered that for many years mainly a symbolic element to express the evolution of contemporary society. The Sendai Mediatek, as I said, represented a turning point for Ito, who reflected deeply about the distance between the starting image, showing columns and thin filaments, and the image of the realized building in which the structural system, rationalization made by Sasaki, transformed the tubular steel columns in a dominant element. Starting from this premise, I will describe you briefly the work of these three couples by the analysis of some significant design process. Starting from the relationship between Ito and Sasaki, there are two projects I will show you are both derived from the application sensitivity analysis method. It is a method of shape analysis developed by Sasaki for the generation of free curved shells, which, assuming that form and aesthetic behavior of the building are two indivisible aspects, can find automatically the most efficient form for the structure. The first time that Ito and Sasaki employed this method is to optimize the greenhouse cover of the green parking wall. Once the office of Sasaki produced a three-dimensional digital model, the computer automatically makes slight adjustments to the initial form, employing an algorithm designed specifically to modify the position of the most stressed node along the perpendicular direction to the surface in order to decrease tensions and displacement around that node. After checking the consequences on the entire structure in terms of stress and displacement, the calculation is repeated until you have no more evident improvement from one step to the next. Figures show 4 stages in the sequences of calculation, starting from the initial form, step 1, to reach the optimal shape, step 46, where the deformation of the structure is reduced by developments of form. So it was possible to achieve a structural thickness of only 40 centimeters. If formal outcome was not satisfactory, designers can modify the design parameters, such as the position of the super points or the thickness of the shell. The other project in which Ito and Sasaki employed the sensitivity analysis method is the Maison Memorial Municipal Funerary Hall. Here, Ito demonstrated a greater awareness about the possibilities that the application of this method could offer. That is evident because he imposed less formal constraints to the cover of the building, which was certainly thought like that to be calculated with this method. So the numerous depressions are best suited to the changes produced by the calculations, so much so that the final thickness of the shell is only 20 centimeters.